then R1 is equal to area of triangle over S minus A. Similarly, you can prove that R2 is equal to area of triangle over S minus B, and R3 is equal to area of triangle over S minus C. Now, we will prove some other formula for X radius R1, R2 and R3. Let us draw a triangle again. And this triangle will be A, B, C. And again, when you extend these parts of AB and AC and then bisect these angles, and when you draw a circle touching all these three sides, side BC and the extended part, that this point is I1 and this is the X radius R1, but this might be E and this one be F. Let us take this angle bisector of A up to the I1, and this is a point D where it is, where this X circle is touching the side BC. This angle is B, this angle is A, and this angle is C. Now, here we'll do the same thing, that tangent to this circle from A, AE and AF are two tangents, and these tangents are equal. Like AE is equal to AF. AE is equal to AF. Similarly, here BD is equal to BE and CD is equal to CF. Now, if we take AE plus AF, then AE plus AF is equal to what? This is equal to AB plus BE plus AC plus CF. AC plus CF. Now we will put this value here so that we get BD plus DC here. That's right, AB plus AC plus BE plus CF. Now we can put BD in place of BE and CD in place of CF. So you will get AB plus AC plus this is BD plus CD. Now what is BD plus CD? See, this is BD plus CD. This will be equal to BC only, BC. Now AB is what? This is side C, this is side B, and this is side A. So you will write AB is side C plus AC is B and BC is A. A plus B plus C, which is equal to twice of semi-perimeter. Now AE plus AF. See, AE is also equal to AF, so we can write twice of AE equal to twice of S. That means twice, 2 will cancel out and you will left with AE is equal to S. That means each AF and AE is equal to S. Now if we take triangle AEI1, in triangle AEI1, in triangle AEI1, tan of this angle is A by 2 and this is also A by 2. So this tan of A by 2 will be equal to what? Now this is perpendicular and this is base. So this will be equal to R1 over AE, or you can say that I1E over AE. Now I1E is equal to what? This is equal to R1 over AE. AE is, which we have proved, that this is equal to S tan A by 2. Now R1 is equal to S tan A by 2. Similarly, you can prove that R2 S tan B by 2 and R3 is equal to S tan C by 2. I hope this will be clear to you. Now we will prove another formula for x radius. As we have proved it that AE was equal to S, if we take triangle I1BD, then you will see that this angle, if this angle be B, then whole of this angle will be pi minus B. Now since this is angle bisector, external angle bisector, so this angle will be pi minus B by 2, and this angle will also be equal to tan pi minus B by 2. Now if we take triangle B I1 and take this point D here, so if we take triangle B D I1, then tan of pi minus B by 2 will be equal to what? This I1D. Now this will be perpendicular and BD. That means I1D over this is BD. So this is equal to cot of B by 2 I1D over BD, and from here BD will be equal to I1D over cot of B by 2. Now this cot B by 2 will come in numerator, and this will become tan of B by 2. This I1D is nothing but this is the x radius, so you can say R1. This will be equal to R1 tan of B by 2. Similarly, you can prove that DC is equal to R1 tan of C by 2. Now this is BD, this is also BD. Now we can write that A is equal to BC, BC is equal to A. Now what was BC? BC was BD plus DC is equal to A. Now what is BD? This is R1 tan of B by 2 plus R1 tan of C by 2 is equal to A. Now take R1 outside, you will get tan of B by 2 plus tan of C by 2 is equal to A. Now, when you will open this, then you will get R1 sine of B by 2 over cos of B by 2 plus sine of C by 2 over cos of C by 2 is equal to A, which when you will further solve, then you will get R1 into sine B by 2 cos C by 2 taking LCM plus sine C by 2 cos B by 2 all over cos B by 2 cos C by 2. This is equal to A. Now this is sine A cos B plus cos A sine B. This will become R1 sine of A plus B over cos of B by 2 cos of C by 2 is equal to A. Now we know that since this is a triangle, therefore A plus B plus C is equal to pi, and B plus C will be equal to pi minus A. So this will become R1 sine of pi minus A by 2 over cos of B by 2 cos of C by 2 is equal to A. Now this is equal to R1 cos A by 2 over cos B by 2 cos C by 2 is equal to A. It will again equal to R1 is equal to A cos B by 2 cos C by 2 all over cos of A by 2. Similarly, you can prove that R2 is equal to B cos A by 2 cos of C by 2 over cos of B by 2, and further you can write R3 is equal to C cos A by 2 cos B by 2 all over cos of C by 2. Now if you take the formula that A over sine A is equal to B over sine B equals C over sine C, a result for circumradius, and from here you can find out that small a is equal to R sine A. That means small a is equal to R sine A. Then put this value here, you will get R1 is equal to R sine A cos B by 2 cos C by 2 over cos A by 2. This is 2, 2, 2, and from here you will get 2R. Now R1 will become 2r into 2 sine a by 2 cos a by 2 cos b by 2 cos c by 2 whole over cos of a by 2. This cos a by 2 will be cancelled out, and you will left with 4r sine of a by 2 cos of b by 2 cos of c by 2. Similarly, you can prove that r2 is equal to 4r cos of a by 2 sine of b by 2 and then cos of c by 2, and r3 is equal to 4r cos of a by 2 cos of b by 2 sine of c by 2. These were the relation between angles circumradius and inradius. So we have studied circumradius, inradius, and scribe radius, or you can say x radius for the scribed circles. Now we will see that what is orthocenter. Take a triangle ABC. This is A, this is B, this is C. Now draw a perpendicular from A, B and C respectively on opposite sides. Let this point be D and this point be E and this point be F. Then the point where these three perpendiculars meet, that point is called orthocenter. This point is orthocenter. And if you join these 3 points D, E, F, a triangle will be formed. The triangle is called pedal triangle. Now we will find this point be O. Now we will find distance of sides and of angular point from this orthocenter. So first of all, let us find the distance of this orthocenter from this side BC. For this, take triangle OBD and triangle OBD. First of all, we have to find out this angle. Now, since this angle is C, if we take triangle ADC, in triangle ADC, this angle C, this is angle 90, and this angle will be, since the sum of other two angles will be also 90 degree, because one is this 90 degree, therefore this will be 90 minus C. And now if this is 90 minus C and this is 90, then this will become angle C. Now this angle C is equal to this angle because of this property, opposite angles. If this angle is C, then this will also be C. If we take these two lines as the intersecting lines, therefore, if this angle is C, then this will be C, and if this will be 90, then this will become 90 minus C. I hope this will be clear to you. Now, if we take triangle OBD, then OD over BD now OD over BD is, if this is angle, this is perpendicular over base, this is equal to tan of 90 minus C, which will be equal to cot of C. Now, OD will be equal to BD cot C. Now, to find BD, again we will take, to find this BD, we will take triangle ABD. Triangle ABD. Now, since we have to find out BD, therefore, BD over AB, this is, if this angle is taken, angle B, then BD, this is base and this is hypotenuse. So, base over hypotenuse is cos of B. So, BD will be equal to AB cos of B. Now, what is AB? Since this side is opposite to angle C, so this will be small c, and this will be equal to C of cos of B. Now, OD is equal to, this is BD, put this value here, you will get C cos B cot of C. Now, since A over sine A, we can say 2 sine A, so B over 2 sine B is equal to C over 2 sine C. This is equal to R, which was the relation between circumradius, sides and its angle. Therefore, from here we can find that C is equal to 2R sin C. 2R sin C. Now put this value of 2R sin C here. You will get OD is equal to C cos B cot C, and then 2R sin C cos B. Cot C is cos C over sin C. This sin C will be cancelled out, and you will left with 2R cos B cos C. Similarly, you can find out that this was OD. Now you can find out OC. Now OC will be equal to 2R, since in OD, which was opposite to angle A, so angle A was absent. That's why in OC, which is opposite to angle C, so this will be 2R cos A cos of B. Similarly, for OE, this will become 2R. Now since this is opposite to angle B, so angle B will be absent. This will be equal to cos A and cos of C. These were the distances of orthocenter from the sides BC, AB and AC. Now we will find the distance of orthocenter from angular points. Now its angular points are A, B, C. To find distance OA, we will take triangle OFA. OFA. In OFA, we have to find, since we have to find out OA, so we will take AF. AF over AF over OA is equal to, now what is AF and what is OA? Let's see once again. If this angle is 90 minus C and this angle will become A. Now since we have to find out OA, so if we take triangle AFO, AOFA, and here AF will be equal to OA, AF over OA will be equal to, if we take this angle, if this was 90 minus C, then this will be equal to what? This will be equal to, in triangle ABD, this angle is C, then this angle will be 90 minus C, and this will be 90 minus C, then this C, and in a similar way, so now to find out distance OA, we will take triangle OAE. Now in triangle OAE, we will write OA over AE is equal to what? This is hypotenuse over base. If you take this angle 90 minus C, so this will be equal to secant of 90 minus C, because this is hypotenuse over base, that's why we have taken here secant, and since this was 90 minus C, so we can write OA is equal to AE cosecant C. Since this line in first quadrant, therefore this will be equal to cosecant C. Now to find AE, we will again take the triangle ABE, and triangle ABE, AB over AE is equal to, now this is hypotenuse, and if we take this angle A, then this will be base, and this will become hypotenuse over base, which is again equal to secant of angle A, which is AB is what? AB is C over AE is equal to secant A, and AE is equal to C cos A. Now if you put this value here, so you will get C cos A over sin C. Now this is OA. Now we know the relation that A over sin A is equal to B over sin B is equal to C over sin C, and if you multiply it by 2, then this is equal to R. Now put the value of this small c from here, and you will get c is equal to 2R sin C. Put this value here, you will get OA is equal to C cos A over sin C. That means 2R sin C cos A over sin C. This sin C will cancel, and this will be equal to 2R cos of A. Now Similarly, you can find out that this is 2r cos A, then OB will be equal to 2r cos B, and similarly OC will be equal to 2r cos of C. These were the expression for distances of orthocenter from sides and its angular points of triangle ABC. Now we will do centroid of a triangle. Now, what is centroid of a triangle? Suppose you have a triangle ABC. This is A, this is B, and this is C. Now, let D be the midpoint of side BC, E be the midpoint of side AC, and F be the midpoint of side AB. When you will meet this point A from this point D, and this point B from this midpoint E, and C with F, then point of intersection of these three lines AD, BE, FC is a centroid where these three lines meet. This is called centroid, and these lines AD, BE and CF, these are called medians. Thus, median is a line from an angular point which bisects its opposite side. So, now AD, CF and BE are medians, and BD is equal to DC, AE is equal to EC, and BF is equal to AF, because point D, E, F are midpoints of the sides BC, CA and AB respectively. Now, let this point be denoted by, let it be O. Now we will find the length of these median AD, BE and CF. Before that, I would like to tell you one thing, that AO, distance AO is equal to 2/3 of distance AD. Remember this property. Similarly, you can say that from distance from angular point to the centroid is equal to the 2/3 of the median BE. This is equal to BO. In a similar pattern, you can say that CO is equal to 2/3 of CF. Now let us prove, or you can say that let us find the length of these medians. To find length of these medians, let in triangle ADC, AD square is equal to AC square plus DC square minus 2 AC DC into cos of angle C, because in these two sides angle C is there. This is by cosine formula. Now this side is A, this side is B, and this side is C. Now since AD bisect the side BC, therefore this will be A by 2 BD, and DC will also be equal to A by 2. Now put this value here, you will get AC square. Now what is AC square? This will become B square plus DC. DC is A by 2, so A by 2 the whole square minus 2B into A by 2 into cos of angle C. Now B square plus A square by 4 minus AB into cos of C. Now by cosine formula you know that cos C is equal to, yes, A square plus B square minus C square over 2AB. So you will get B square plus A square by 4 minus AB into A square plus B square minus C square over 2AB. Now this AB will cancel out and solve this. This will be A square by 4 minus A square minus B square plus C square. This is by 2 and by 2. Now this AD square will be equal to B square minus B square by 2. This will become B square by 2. A square by 4 minus A square by 2. This will be equal to minus A square by 4 and plus C square by 2 plus C square by 2. So when you will take LCM, this will be 1 by 4 into 2B square plus 2C square minus A square. You can say AD square is equal to 1 by 4 2B square plus 2C square minus A square. Now when you take AD, this will be equal to under the root of 1 by 4 2B square plus 2C square minus A square. Then when you will take 1 by 2 outside, you will get 1 by 2 root of 2B square plus 2C square minus A square. This is the length of median AD. In a similar pattern, you can find out length of BE. So length of BE will equal to 1 by 2. Since here angular point A, so that's why we take minus A square. When it will be angular point B, BE, then this will become under the root 2A square plus 2C square minus B square. And for CF, this will become 1 by 2 under the root 2A square plus 2B square and minus C square. These are the length of medians AD, BE and CF. Now, so AD was 1 by 2 under the root 2B square plus 2C square minus A square. Now if you want to convert it into cos of angle, then again applying cosine formula here, cos of A is equal to B square plus C square minus A square over 2BC. So this here minus A square will be equal to 2BC cos of angle A minus B square minus C square. And when you put this here, so you will get AD is equal to 1 by 2 under the root 2B square plus 2C square minus 2BC cos A minus B square minus C square. And this will become 1 by 2 under the root B square plus C square minus 2BC cos of A. So this is the median AD in terms of cosine of angle A. In a similar pattern, you can find median for CF and BE respectively. So AD was under the root B square plus 2C square minus A square 1 by 2. Now put the value of A square from cosine formula. Cos A is equal to B square plus C square minus A square over 2BC. So this will be equal to minus A square is equal to B square minus C square plus 2BC cos of angle A. So this will become AD is equal to 1 by 2 under the root B square plus C square plus 2BC cos A. In a similar pattern, you can find AD, this is BE is equal to 1 by 2 A square plus C square plus 2AC cos of angle B, and CF is equal to half whole under the root A square plus B square plus 2AB cos of angle C. Now we will find the angle which median makes with sides and angular point. To find this, we will take sine of beta over DC is equal to sine of C over AD. This is sine formula. Now we have to find out sine of beta is equal to DC over AD into sine C. Now what is DC? DC is A by 2. So you will get A by 2 into 1 over AD into sine C. We have just proved that AD is equal to 1 by 2 whole under the root 2B square plus 2C square minus A square. Put the value of AD from here in this equation, you will get sine of beta is equal to A by 2 1 over 1 by 2 root of 2B square plus 2C square minus A square into sine C. This 1 by 2 and 1 by 2 will be cancelled out, and you will left with A sine C over whole under the root 2B square plus 2C square minus A square. So this is the angle made by this median AD with the angular point A. Now we will find the angle which is made by this median with side BC. For this also we will apply sine formula here. This is sine theta over side AC is equal to sine C over opposite to this side is AD. So sine theta will become AC over AD into sine of C. Now, what is AC here? AC is B over AD sine of C. Now, again put the value of this median AD, which was equal to B over 1 by 2 whole under the root 2b square plus 2c square minus a square into sine C. Now, the sine of theta will be equal to these two will go in numerator and you will get 2b over whole under the root 2b square plus 2c square minus a square, and here you will have sine C. Now, this is how you will find the length of medians and the angle made by this median with the angular points and with the sides of the given triangle. Now, we will find area of a polygon. First of all, what is a regular polygon? Suppose we have this with 8 sides, with 6 sides, with 4 sides, or with n sides. So this is called regular polygon. Therefore, regular polygon is a polygon in which all its sides are equal and all its interior angles are also equal. So let us take these three sides of a regular polygon. Let this be A, B, C, and then D. And let this point O be the center of this regular polygon. Now, since all sides are equal and all its interior angles are equal, therefore this center point O will be the circumcenter as well as incenter of this regular polygon. Therefore, we can say that OB and OC, since OB circumcircle will pass through all these angular points, therefore OB and OC we can take as a circumcenter, and this is equal to capital R. And if we draw perpendicular from here, from point O on side BC, let this point be E. Then this point will bisect the side BC, and this distance OE will be in center small r. Now, we know that angle made by these sides on the center, and sum of all the angle is given by n minus 2 into pi. Now, if there are n sides, then each angle will be equal to n minus 2 pi over n. Or we can say that if there are n sides, then each this angle will be equal to 2 pi by n. And since this is in center, therefore it will bisect this angle, and this will be equal to pi by n and pi over n. This is capital R, and this is small r. Now let us find the result for this capital R and pi by n. Let its side be a. Since it bisect, therefore this will be a by 2 and a by 2. Now to find capital R, that is circumradius, you will take triangle OBE. In triangle OBE, OB over BE will be equal to, this is what? This is hypotenuse over perpendicular, and this will be equal to cosecant pi by n. Now this OB is equal to R and BE is a by 2 is equal to cosecant pi over n. Now this R will be equal to a by 2 cosecant pi by n. Therefore, here is the result for circumradius, and that is a by 2 cosecant pi by n. In a similar pattern, you can find out small r in triangle OBE only, OE over BE. This is base over perpendicular will be equal to cot of pi by n. So this will be cot pi by n. OE is small r, BE is a by 2 cot pi by n. Therefore, small r is equal to a by 2 cot pi over n. Therefore, in center becomes a by 2 cot pi over n. Now,